This is a video for the final review in my Calculus 1 class. The directions say to evaluate each integral. So let's take a look at problem 1. Suppose we have the integral from -1 up to 0 of x squared plus 5x dx. So this is 1/3 x cubed plus 5/2 x squared evaluated from -1 to 0. So we're going to apply the fundamental theorem. I'm going to replace x with 0. And when I do, I get 1/3 times 0 cubed plus 5/2 times 0 squared. Now, I'm going to go minus, and then I'm going to replace x with -1. And I'm going to get 1/3 times -1 cubed plus 5/2 times -1 squared. So this is 0 minus, in parentheses, I get -1/3 plus 5/2, which is 1/3 minus 5/2. So notice that the lowest common denominator here is 6. And so I'm going to build each fraction to have a 6 in the bottom. So in the second fraction, I multiply numerator and denominator by 3. In the first fraction, I multiply numerator and denominator by 2. And so this is 2/6 minus 15/6, right? 5 times 3 is 15. And so the correct answer here is -13/6. That's how we do problem 1. Problem 2, we have the integral from 0 to 1 of 1 minus x to the 9th dx. So this is x minus 1/10 x to the 10th, evaluated from 0 to 1. Replace x with 1. We get 1 minus 1/10. Replace x with 0. We get essentially 0. If we do the same idea as problem 1, right? But this is 10/10 minus 1/10. And so the correct answer here is 9/10. That's problem number 2. Let's take a look at 3. Suppose we have the integral from 0 to t of x to the 4th minus 8x plus 7 dx. Okay? And so this is 1/5 x to the 5th minus 4x squared plus 7x. But we evaluate from 0 up to capital T. And so if I replace x with t, I get 1/5 t to the 5th minus 4t squared plus 7t. If I replace x with 0, I get 0. And so the correct answer here is 1/5 t to the 5th minus 4t squared plus 7t. That's problem 3. Let's take a look at problem 4. So suppose we have the integral from 0 to 1 of 1 minus x to the ninth dx. Now, this can be done by u substitution. And so I'm going to let u equal 1 minus x. My du is negative 1 dx. dx is negative 1 du. Okay, now we have to transform those x limits to u limits. Okay, now when x is 0, u is 1, right? I'm plugging in up here. When x is 1, u is 0. And so this is negative the integral from 1 to 0. Okay, the negative comes from the du of u to the ninth du. But if I swap the limits, I change the sign. So this is the integral from 0 to 1 of u to the ninth du, which is 1/10 u to the 10th evaluated from 0 to 1. But this is 1/10 minus 0. Okay? And so the correct answer here is 1/10. And that's how we do problem number 4. That's a pretty good stopping point for this video. This is a video for the final review. And the topic was evaluating an integral, and we looked at the first 4 problems from that topic. So, okay, thank you.